Slicing in Python allows us to extract specific portions of sequences, such as a list or a string, using a really concise syntax that's based on indexes. Let's quickly define what we mean by an index. You can think of an index as the position of an element in a sequence, and Python uses zero-based indexing, which means that the first element of a sequence has an index of 0. Slicing is implemented using the following syntax. You can see that we specify a start, stop, and step. This means we're selecting elements starting from the index start up to, but not including, the index stop, with an optional step parameter indicating the increment between elements. Slicing has some sensible defaults. If we omit start, it defaults to 0. If we omit stop, it defaults to the end of the sequence. And if we omit step, it defaults to 1. It's important to note that the stop index is exclusive. This means that the element at the stop index is not included in the slice. Python gives us some pretty cool shortcuts to use in slicing. For example, this sequence slices from the beginning up to index n. This sequence simply reverses the order of all the elements. Negative indices count back from the end of the sequence. It's also worth noting that slicing gracefully handles out-of-range indices. If the start or stop indices exceed the sequence boundaries, Python adjusts them to fit within the valid range without raising an error. By mastering slicing, you gain the ability to efficiently select and modify specific segments of data with minimal effort. This is particularly valuable in things like data analysis, where you might need to extract, summarize, and/or transform data for processing. Additionally, understanding slicing can help improve the readability and performance of your code, making it easier to implement complex operations for common tasks such as automation and search.